Hi everybody, I am Dr. K.S. Sharma, Chemistry, IIT NEET coaching faculty member, working throughout India as guest faculty member for the last 3 decades. Okay, let us start discussing about organic chemistry. As you know, all the matter is divided into two types, living and non-living. The chemicals present in the living organisms is called organic chemistry. As you know, the smallest and characteristic particle of any matter in the universe is called chemical. And study of such chemicals is nothing but chemistry. In that, the study of chemicals present in the living organisms is known as organic chemistry. Okay. So, first of all, what is the base to say whether a compound is organic or not? First of all, question is the same. How can you say that a compound is organic? Okay. Any compound containing carbon and hydrogen which are connected through a covalent bond is known as organic compound. For example, ammonium cyanide NH4CNO. If it is strongly heated, it will rearrange into NH2CO NH2. So this is inorganic compound, ammonium cyanide. This is organic compound. Observe here, in this case, NH4 plus CNO minus, it's an ionic bond between these two. Means hydrogen here, carbon here are connected through ionic bond. Whereas here, hydrogen here and carbon here are connected through covalent bond. However, carbon is connected to nitrogen, nitrogen is connected to hydrogen. Okay, but the link is totally covalent. So, like that, any compound containing carbon and hydrogen which are connected through covalent bond is known as organic compound. The same molecular formula is same, but structure is different. In the molecular formula, NH4CNO, NH4CNO, but here the structure is like ammonium cyanide, two ions, and here like this. So, this urea is organic compound. This ammonium cyanide is inorganic compound. I hope you got the point. Any compound containing carbon and hydrogen which are connected through a covalent bond is known as organic compound. This is the first point to know what is the difference between an organic compound and inorganic compound. Well, so now you came to know that whatever is organic compound, and on the basis of the chemical structure, how can you say that a compound is organic or inorganic? Good. Now, coming to the next. First of all, to the organic chemistry, one theory was proposed, that is vital force theory. Vital force theory says what? A vital force is required for the formation of an organic compound. That means any organic compound to form, a vital force is needed. Vital force means prana shakti. So, unless that vital force, organic compound is not formed. This is the concept given by vital force theory. So, according to vital force theory, organic compounds must be extracted from the living organisms rather than preparing in the lab. Simply speaking, organic compounds cannot be prepared in the lab. They must be extracted from the organic materials only. That means, from a living organism only, we can extract organic compound. Like the vital force theory proposed. But scientists felt what? To extract from a living organism, we are supposed to kill a living organism. Unless killing, how can you get what is a bulk of organic matter? A small amount means okay, we can cut. But heavy matter is required means we must kill it. So they looked for many things and ultimately came to know that organic compounds also can be prepared in the lab. Just as they said now, the ammonium cyanide inorganic compound on strong heating has become organic compound. This was the first organic compound prepared in the lab. It was done by Frederick Waller. Frederick Waller has prepared organic compound in the lab, and he came to know that he came to a proof that organic compounds also can be prepared in the lab. So it is the violation of the vital force theory. That means vital force is not required for the preparation of organic compound. Later on, coal they prepared acetic acid. Like that, many scientists have extracted many organic compounds, prepared many organic compounds without extracting from the living organisms. So scientists came to know that organic compounds also can be prepared in the lab. But the problem is what? Problem is that organic compounds preparation in the lab is highly expensive. But extraction from the living organisms is cheap. So they came to a conclusion that organic compounds are profitably extracted from the living organisms rather than preparing in the lab. Thus, we have got a conclusion that organic compounds are profitably extracted from the living organisms rather than preparing in the lab. So, now we have got the idea about whether a compound is organic or not. And secondly, we have got a conclusion that organic compounds can be extracted in the lab, from the living organisms or can be prepared in the lab. For that also we have got the conclusion. And ultimately we came to know that organic compounds can be prepared in the lab also, but it is expensive. So this is what is the fundamental idea about the organic compound and their preparation. Now the next one, structure of the organic compound. Structure. Coming to the structural features. The basic unit of all organic compounds is carbon. So carbon is the main component of all the organic compounds. And hydrogen is the helper. Hydrogen helper. So all the organic compounds contain carbon and hydrogen. In that, the basic units of all the organic compounds are made up of carbon and subsidiary valencies are satisfied by hydrogen. So formerly organic compounds were also called hydrocarbons because they are all the compounds of carbon with hydrogen as the helper. So they are called, hydrogen is known to be somehow like a substituent. So substituent is named first, that is why hydrocarbons, like that they called it. Later on they came to know that not only carbon and hydrogen, many other heteroatoms are also present in the organic compounds, oxygen, nitrogen, sulfur, like that. Apart from carbon and hydrogen, other elements are also present. So hydrocarbons is not a suitable word, like that they felt. But hydrocarbons, major components of organic compounds were separately called hydrocarbons. So organic compounds are again divided into two types: hydrocarbons, hydrocarbons containing heteroatoms, like the organic compounds. Hydrocarbons containing heteroatoms. Hydrocarbons means carbon, hydrogen are only present. Heteroatoms means carbon, hydrogen, oxygen or nitrogen, something like acetic acid, CH3COOH. Here we have carbon, hydrogen and oxygen. Pyridine means C6H5NH, C6H6N, something like that you can take. Like that, many compounds are there. In them, carbon, hydrogen are present. In addition to that, heteroatoms are also present. So simply speaking, for every organic compound, carbon is compulsory, hydrogen is also necessary. Without carbon and hydrogen, organic compound is not possible. In addition to these two, some other heteroatoms are also present. I hope you got the clarity about organic compounds. Coming to the structural features, as carbon is the main unit, we are supposed to know how carbon is present in the organic compounds. In all the organic compounds, carbon has three hybridizations. But the three hybridizations are sp3, sp2 and sp. So simply speaking, in all the organic compounds, carbon has tetracovalency with any one of the hybridizations sp3, sp2 or sp. That means in all the organic compounds, carbon must have 4 covalent bonds. Covalence is 4. In addition to that, it must have any of the hybridizations sp3, sp2 or sp. How can you say that a hybridization is sp3? sp3 means all bonds are sigma bonds. All sigma bonds. So carbon has all sigma bonds in sp3. Okay. Carbon has 1 pi bond. Okay. 1 pi bond. 1 pi bond, the remaining are covalent bonds. Sigma bonds. Like that. Then it is sp2. Next, sp means 2 pi bonds. 2 pi bonds, 2 sigma bonds, like that. In addition to that, sp3 other possibilities are all sigma bonds is the first case. In addition to that, second case, carbon with localized negative charge. Localized negative charge. Localized negative charge means what? Carbon must bear a negative charge. It should not have a possibility to delocalize. That means it must not have double bond on the next carbon. If this is negatively charged carbon, to which the next carbon is not having a double bond, then this carbon has no chance to delocalize. If double bond is present, then it can delocalize. In such a case, it will become sp2. Okay, so carbon with localized negative charge is known to be sp3. So sp3 carbons we have got all sigma bonds, carbon with localized negative charge. These two possibilities are present. Carbon with all sigma bonds or carbon with localized negative charge. These two are known to be sp3 carbons. Now coming over to sp2. Carbon with 1 pi bond. This is okay. In addition to that, this is first possibility. We have 4 types of sp2 carbons. Carbon with 1 pi bond. Second one, carbon with unpaired electron, means free radical. Third one, carbon with positive charge. And fourth one, carbon with delocalized negative charge. As I said, it must have alpha double bond. Means negatively charged carbon must have double bond to the next carbon. In such a case, it will delocalize so that it will become sp2. But sp carbon, it has only one possibility, that is 2 pi bonds. Now let us take the examples. Take a compound like this. So, if nothing is mentioned, the remaining valences are all satisfied by hydrogen, I said no? That is why, if carbon is mentioned, not mentioning the remaining 3. The remaining 3 you must understand that the remaining 3 are hydrogens. So, it is nothing but CH3. It is nothing but CH2. It is CH2, CH2, CH, like that. In this is sp3. If you have a double bond here, it will become sp2. Okay, one more double bond here. Now you see, this carbon is having 2 pi bonds. So, it is sp. It is sp2. It is again sp2. Okay, so carbon is having a triple bond. Then also it is known to be sp. So this is also sp. Similarly, we have a carbon with double bond to oxygen. This is also 1 pi bond is required, whether it is with carbon or any other atom. So this is also sp2. Now I hope you have got the idea about, complete idea about the hybridisations of the carbon. Okay, any doubt, any question, anything else? So far we have learned about what is organic compound, how to recognize an organic compound, and what is the structural feature for the organic compound. In the organic compounds, what is the major component, what is the helping atom, what are the possibilities to say whether whichever is sp3, sp2 or sp3 carbons. This type of things all we have learned so far. Any doubt, any question, anything else? We will discuss later the complete detailed structures of general organic chemistry in the next class. Any doubt, any question, anything else, you can put in my WhatsApp. My WhatsApp number is 94920502000. Thank you.